Hi guys, welcome to another episode of Tech Tips with Metro Home Theater Group. I am Adam Rogers, and we have a special guest today. We have Claire.
Claire.
Hi, Claire.
Good to be here.
Good,
I'm doing great.
So today's episode, we're talking about networking 101. We're going to be talking about different, pieces, the kind of the basics to get everything set up and going. Yeah. From what's a modem, what's a router, what's a switch, what's a wireless access point. All the way up to more about the technical side of the IP addressing scheme. So without further ado, we're going to go ahead and jump in. Well, again, I've got Claire with me today.
Glad.
Claire, kind of give us a background of kind of your history.
Well, I started actually in years ago in maintaining our own company's hardware and software and network system, and I kind of learned most of this the hard way. Because a lot of things have changed over the years, and I had people that were selling me stuff I didn't need and wasted a lot of money, and over time I just kind of learned and evolved and eventually became to where I started IT and training, did a number of years of training on networking and other computer IT information, and now I just kind of do that and have fun talking about the things I learned.
Great.
And
very cool.
So it's been fun.
Very cool, very cool. So again, guys, the other good thing about today is we brought back the free giveaway. So that's back. So ask your questions for our show today. If you have any good questions for the show, the best question of the show during the live stream will win this thing. Whoop, right there. We're giving away the IB HD AOC 30 fiber HDMI cable. Great piece. It's a 30-foot. You guys can put it in your showroom or try it out for yourselves and see how you like it. But we're giving that away today. So again, ask your questions. The best question of the show will be given that HDMI cable. So definitely keep an eye on that. So without further ado, we'll go ahead and just jump kind of jump right in.
Okay, how do I ask the question so I can win the cable?
Oh gosh, unfortunately, because you're on the show, you're not winning today.
Oh man.
So with that, we'll go ahead and jump right in. So kind of fill us in a little bit. What's when you brought some artwork with you, and you brought some boxes with you, and some different devices and whatnot. Let's start at the head end. Let's start with the modem. Yeah,
at the very beginning, you have to understand all the pieces that are inside of your network, because there are a lot of configurations of hardware out there, but they all contain the separate elements that we need to be aware of. And I drew a kind of a rough graphic here just so it would have something to point at conceptually as we talk about it. Your ISP, or the internet out there, we have to be able to get it into our site. So somehow we've got to have a way to send that information, and basically the way the world talks nowadays is over TCP/IP over Ethernet. And virtually everything works that way. But we've got to have a way to take that information from the ISP, which is a different protocol, and get it into our network, which works over TCP/IP. So the way we do that is with a modem. And that's actually also sometimes called a gateway, and that converts their protocols into the TCP/IP protocols. That brings them inside our site to our network. Once we're there, we have to decide, how do we move this stuff around inside of our network now? And that becomes the job of the router. And now I've drawn each one as a separate piece of hardware here because it's kind of easy to understand the concepts that way. And a router now starts to route the traffic. Where do I want it to go? Do I want a wireless access point? I need to talk to a TV that's got an Ethernet connection. I want to run a home automation system. How do I get the information there? Well, the router directs how we accomplish that. The problem is a router may only have no ports, or it may just have one or two ports.
Right.
And so we have to have a way to spread those ports out now, and that's where the switch comes in. A switch is a piece of hardware, and it actually does two things for us that you need to be aware of. Because Ethernet has a length limit.
Right.
And it's 100 meters for basically Cat5e or Cat6 or Cat6a.
Right.
And so we've got a 100-meter length, but the switch also repeats that broadcast.
It takes the signal in and then again re-amplifies it and sends it back out.
So it'll take it, re-amplify it, and send it back out. So the reality is now we can increase those lengths so they're a little less of a crucial factor.
Right.
But you need to be mindful of that, and that can sometimes affect speed too.
Right.
And so once we go to that switch, we can have a variety of ports. A switch can be daisy chained to another switch, and so we can get all the ports we need to bring our devices out there. And off that switch, we may go to a wireless access point or a group of them. We may go to a PC. We may go to a printer.
Just whatever network device
needs
to be
network
hardwired
device
in.
we need to talk to.
Very cool.
Now let me just mention one thing that I think is really helpful to understand today, and that is that some of the specified theoretical limits of the wireless access points actually look like they exceed gigabit Ethernet, which is what most things run at today. But the reality is it's much more susceptible to interference, and it's more susceptible from a security standpoint. And so the real throughput that you're going to get, you're going to be better off hardwired where you can.
Right.
And sometimes we don't have a choice, so we're going to go and we're going to do Wi-Fi access points.
Yep.
But for the most part, if you can hardwire, you're going to be better. Now, as the industry moves toward 10 gigabit Ethernet, you know, that line of thought may change a little bit.
Right, right.
But for now, if we can hardwire, it's better.
Great. So you have with us here. We've got a couple different devices. Let's look at a modem. What would we commonly see from the different service providers? Let's say
this is kind of what we'd see from the service provider, the modem, and you get a lot of lights up front. This is a typical one that's been around for years and years and years, and it's a workhorse in the industry. The Aris are actually pretty good. And the reality is, all of those separate devices we talked about, this single device does.
Yeah.
As you can see, we bring the cable in, and so that becomes the gateway, or puts it into the modem.
This here, I think.
This way. Okay, there we go.
Perfect. We'll get that top-down shot.
Yeah. And then we'll have a switch here. One of these will be a wide area port where it comes in, it becomes a router, and in this case, a switch. And in this particular case, it's a wireless access point as well. So all the separate pieces we talked about are all in this one device.
Correct, yeah.
Now there's some good and some bad to that.
Of course. So in this instance, you know, in the, you know, Joe Schmo down the street he just wants to have Wi-Fi in his house because he wants to, you know, browse on YouTube or whatever else, this handles everything he needs.
He may well do everything he needs.
Right.
And if they can get it into a point where the coverage is good, that works well. The negative side, and you have to realize the cable standpoint a little bit on this, their goal is to bring internet to your house.
Yep.
And to make sure Wi-Fi's on, and then that's their part.
And then they're done.
And then they're done.
And then they leave.
And the problem with this approach of everything together is that isn't always the place they bring it in is not always the most optimum place for, say, a Wi-Fi access point.
Right.
And so you get a lot better network if you can build your network behind the modem. Now, if you're in a situation to do that, and we'll talk about some of that a little bit, and use your own pieces behind it, you're going to wind up with a lot better network.
Right. So
But the thing you have to watch on that is if you do, you have to tell the cable company you want this in bridge mode.
Bridge mode.
They'll know what that means. And that you want it, you're going to put your network behind it. And you want to turn Wi-Fi off.
Yep.
You don't want to have more networks than you need out there. And if you do that, then this becomes simply a modem. That's all it does. Takes the data from the internet, puts it inside our house into our equipment, and then we build our network behind it.
Great.
That will give you inexpensively, because network stuff today is not too expensive anymore.
Yeah.
And you can build a much better network by doing that. But for a small home or situation, that may well be everything you need.
Great.
And
so great. So so this of course when we have it set up like that, when we're designing systems for different services, whether it be for surveillance systems or for control systems or whatever else, usually in those cases we want something a little bit more robust than what normally comes from the ISP.
Definitely we do.
So in this case, we would really want to go ahead and convert that over to the bridge connection.
Yes.
Okay. So in that case, then this becomes just a
modem?
A modem. It just converts it from whatever the service provider is giving it to our local connection there inside there. So what comes next in line?
Generally, if we're going to go next in line, then we're going to just do a modem. And I want to show 3 devices here for a minute because you can't tell just by looking at it what it is. This is a modem, but it has 3 ports, and none of them are called a wide area network. This is a higher end modem where we can go in and configure each of those ports to do whatever we want it to do, and it's a really good one. But if I then take this device, that's got 4 ports, 5, but that's a switch only, it's not a modem.
Right.
You can't tell just because it has ports and it doesn't say wide area network.
Right.
And then we can take another one that looks very much like that one, and that's a modem and a switch.
It's got everything in it.
It's got everything.
It's got a lot in it, yeah.
And you can see it's much smaller, and it's also very high performance.
Yep.
And you can configure it any number of ways. So you need to know the hardware you're using. You've got to know which piece is which, and if the pieces are combined and doing multiple functions, you need to understand that. And most of them have a web interface now, so you can go in and do the configurations fairly easily.
Nice.
The first thing you want to do is kind of map out your network in a graph, sort of like I did here.
Yep.
And so you know what pieces you're going to put in and where you're going to put them and why.
Yep.
And then once you do that, you'll start to have a pretty good network, and it sets up fairly easily.
Very nice.
The problem people have is they just kind of put a piece in, and then they add a piece 2 months later and 3 months later, and the thing just kind of evolves in spaghettis.
Yeah,
And they don't have a wire, so they do some sort of inventive way of hooking something together, and then later it comes back to haunt you.
Right.
So really plan your network, and even when you expand it, take a look what you got, plan it out so that you can continue to grow with a good functioning network.
So on that subject then of planning out the network, making sure that everything is nice and orderly, something that I do on my setup is I actually have a spreadsheet that I've designed, and in fact I believe it's available now. If it's not available now, it'll be available really soon on our website if you go to any of our IP cameras or if you go to the download page.
Yeah.
Basically it's my worksheet that I use.
Oh,
and
awesome.
So the nice thing is that I have things broken out. I like to keep things in a certain fashion on my network. The first, say, 20 IP addresses. So usually the .1 IP address will be your router in most cases. And what I like to do is I like to put the other networking equipment, whether it be access points or managed switches or whatever it may be, that's a network management device. I like to keep within a certain range, and then from there I have like my media devices, my media streamers and whatnot, and then even into surveillance I have that down in its own section of IP addresses.
Man after my own heart.
keep everything organized, right?
Yes, absolutely. Well, the reality is if it's in the right IP range, it's going to communicate. Networks are very logical in the way that they work.
Right.
And the more logical we can be in the way we approach them, and I like that approach, and I do the same thing. I have certain ranges for servers, certain ranges for printers, certain ranges for VPN connections, and then I know exactly as soon as I see a number what I'm talking to or what it is, and
right.
It really makes it easier later on. And a lot of people just plug them in and they all work and they go, good enough.
Good enough.
Yeah, and the reality is Ethernet is fairly flexible in the fact that it will try and work away and drop transmission rates, and it'll keep talking, even though it's not talking as effectively as it could.
You're right.
In some ways, that makes it kind of a tough part to troubleshoot because it's working and it's connecting,
right,
but it's not working as effectively as it could.
As well as it
so
could,
apply the logic, map it out, know which pieces of hardware you're using, how they're going to fit together,
right,
and how they're going to fit in your site.
Yeah.
Location-wise, and you'll have a much, much better network.
So if we map everything out, keep everything really organized, from start to finish, before you even get to the job site, you should be mapping it out physically, one, so know where everything's at, but also mapping out your IP addresses, make sure everything's set up.
Yeah.
Using some other scan, if it's an existing network, some things that I like to do would be use like an IP scanner on like a laptop.
Absolutely.
Get an idea of what's already there.
Yes.
Finding out where the DHCP range is or the pool or whatever, and using that tool to kind of figure out where everything goes. So, actually, real quick, guys, one more thing. Again, ask your questions. Lots of questions is what we're looking for. Oh, are we down at the moment? Okay, we are down at the moment. All right. We're recording it still, though. Okay, guys, you'll see this later on. We're recording it, so we're no longer live at this point, but maybe it'll pop back up again. So if it does, we'll see you at that point. But we're going to keep going. So with that in mind, we'll go ahead and just keep talking about the networking setup and whatnot.
Yeah, and that's one of the most crucial tools for working on a network is a way to scan inside that basically ping all the devices, and you can see what's out there and how it's set up. Otherwise, it gets really difficult to figure out what somebody's done before you.
Now, everyone has their favorite program. What's your favorite scan tool?
I use iNet Monitor, which is on a Mac. I do most of mine with Macintosh, and so I use that one. It has an iOS version as well.
Okay.
And it's a good one. It's fairly inexpensive. The thing you have to watch for is there's some free ones out there, but they'll only scan like 20 IPs or something.
Right.
And unless you do the paid version. So you want to get the paid version so that you can get the whole thing. Most of them are inexpensive, and there are some that are free. And
some good ones. I like to use Advanced IP Scanner, but I'm a Windows computer user, and so
there's a Mac version of that as well.
Is there? Okay, I didn't know that. I'll have to find that. Very cool.
And that is a good one.
Good. And so that again, laying everything out, making sure everything's nice and clean and orderly and whatnot is definitely the way to go. Let's talk about IP addresses.
Okay.
And what those look like, how they're laid out. What do we see when we're external? What do we see when we're internal? Let's kind of take a look at that and see what happens.
Okay, I'm going to put some graphics up here, and when you first look at them, they're going to look a little bit confusing because there's a lot of information. But if you understand just the basic concept of what the network's trying to do, then it makes the addressing much simpler.
Very nice.
So don't let the graphic complexity make it seem more complicated than it. Let me get rid of this just so So we don't have overflow. Our graphics are hard to see as it is.
Get a lot of information on it.
Yeah.
So. Very nice.
So I'll just point some out here. So this is an actual IP address. It's what's called a public address, which means it's routable, it's seeable by the world.
Right.
And all of your external addresses, they're called on your router, are going to be a public address. Your ISP is going to give you a public address or multiple public addresses,
right,
so that you can talk to the outside world.
Right.
But we have two parts of a network. We have the physical network, which is the wire, the interface cards that physically hook it together, and they have incredibly complex streams of numbers.
Right.
Mostly winds up being in the digital world, the binary world of ones and zeros.
Right.
And if it had to just go out and find those, it would be a lengthy process to look through 4 billion addresses to find you.
Yeah, for us as humans, it's much more difficult to do that. So.
And so we put them in a logical address, which is the IP numbers that you see up here that you're familiar with. They're octets, but they relate to digital equivalents.
Okay.
And so that breaks it down into a logical network.
Right.
Now, the best way to think of that I can think everybody can relate to is USA phone numbers or any other country phone number. We've got 4 parts. And the reality is, if we want to call Daytona Beach, Florida, this particular number, we need to get to the United States. That's 01.
That's the first one.
That's the same as our logical network up here.
Yep.
And from there, rather than scan the whole United States,
right,
we can go to Daytona Beach area code, which is 386. So now we know we're in the area here.
Helps to bring it down a little bit.
And then we get to a local prefix. 555 isn't a real one, by the way.
Yep.
But that'll get you into a local like a Holly Hill or an Ormond Beach, so you're kind of local. And then the last 4 become the number of the physical phone that you're going to call.
Okay.
And so the same things happen with the networks. It's really that simple.
It just helps to kind of narrow down location base. That way we're not scanning a massive amount of IP addresses just to send one bit of information to it. Okay,
so
very
it narrows
nice.
it down very quickly. Now, as far as the Class A networks, the only thing you really need to kind of be aware of on that is a Class A network says they assign the first part, which would be in this case the 208, and then you can do whatever you want with the rest, your local hosts.
Okay.
So you have a lot of them.
Okay, yeah.
That would be 255 times 255 times 255.
That's a lot.
It's a lot.
Yeah. So now this is actually new to me. I will be perfectly honest with you. I did not know that. I had always seen what a Class A or Class B or Class C, but having it written out like this is very informative.
Really
so
makes
I appreciate
it clear.
that. Yeah, definitely.
And Class B simply means you're buying the first 2 pieces from your provider.
Right.
So that would be in this case the 208 and the 33, and then the last 2 you can do whatever you want to with.
Right.
And again, that would be 255 times 255. That one I do know is 64,000.
64,000.
So
okay.
that's usually enough for most of us to handle our site installations.
Right.
A Class 3 basically, or a Class C, you basically buy the first 3, which in this case would be those, and then you can have 254 hosts there.
Gotcha.
0 to 255.
Now, in most cases, when we're looking at a residential address, there's not a whole lot happening with that. We don't need multiple IP addresses for like a residential setup or whatnot.
No.
So in most cases, they would see just this number, the IP, that the ISP is giving them.
Yep.
This is your WAN IP address, or your what does that stand for? Wide access network.
We're wide area network.
Okay.
Yeah.
And so at that point, that's the number that you're given for that.
Yeah, they'll give you that number, and usually if you've bought a static one, they're going to give you a gateway number, so you'll actually have 2. That gets you to the right section of them,
Gotcha.
And then that gives you the one to use, and that's the one you use to get to your router from the outside world.
Interesting.
And if you have a big situation where you want to buy more, you can buy more local addresses that are fixed.
Right.
The thing that most people don't realize with that is that when they buy more external IPs, somehow most of us think we're buying more bandwidth.
Yeah, no, we're not.
And we're not. It's all sharing the same bandwidth.
Yeah.
It's all sharing the same bandwidth.
So it's still just the one piece of copper, but we've got that. So let's talk about the internal IP addresses really quick, and then what we're going to do, we're going to go ahead and after we get done with that, we're going to wrap it up, and we're going to say our goodbyes. And we never did make it back on live, did we, guys?
No bandwidth.
Okay.
Okay.
All right. So we'll go ahead and run with it then.
Okay. Now for the thing you want to remember for the private IP addresses, and this is crucial from a security standpoint.
Yeah.
I mean, if you have a lot of money, you think, oh, that's great, I'll go out and buy a whole range of IPs and everything I have is available, and you don't want that.
No.
So there are several ranges that are private, which means they won't cross a router.
Okay.
They're what's called non-routable numbers. And so you can use those inside of your network, and 25,000 people can use the same one, and it doesn't matter
Right.
because they never cross their router to the public realm. One of the most flexible ones is 10.000, and basically that gets you the 10.255.255.255, or you'll see it posted as 10.x.x.x.
So that's like our Class A.
That's our Class A,
what we were
yeah.
talking about before.
And
okay.
it's really flexible because even if you don't need all the numbers, you can maybe define, okay, 10 gives my private network, and then I've got, in a large installation, maybe a building that I go to that I'll use for the second number, and a department for the third, and then the local network.
Interesting.
So you can kind of use that to route your internal traffic, even though you don't need anywhere near that number of addresses.
Right.
So it's really flexible. And from real world experience, I can tell you a lot of people like it because it's easy to type.
Nice, yeah.
And it's easy to remember.
Very easy, yeah.
And that works great. 10, 10,
Yeah.
10, 10, 10. Okay,
Yep.
there we go. One of the more common ones that you see, particularly in commercial pre-programmed routers that web interfaces, the 192.168. And basically that part is fixed, 192.168, and you'll see it .x.x, which means we can do the 255 times 255. So anything in there we can do.
Gotcha.
And so that you see all the time.
I was going to say that's a very common one. Anyone who's dealt with residential routers or anything else has seen that.
Sees it all the time.
And a lot of people still use it. I personally still use it
Yeah.
myself for a lot of my stuff.
And it doesn't matter. One's not different or more professional or anything like that.
Yep.
I've heard people say, oh, well, the 10s are for businesses and the 192s, 168 are for homes. Like, that's really not relevant.
Yeah. Very
Now,
cool.
there is one that is out there that's non-routable, and it's the 172.16 up through 172.31. That's not used very often, but it is actually a non-routable address.
Okay.
And so while it's there, I see that mostly where somebody has this, say they're in the 192 range or the 10, and they decide that they want to add a yes network or something that's totally different IP range.
Gotcha.
And so they'll put that in with say that one, which is again a non-routable number. One last one I want to talk about a little bit, because you see this quite a bit, is the 169.254. And that's what's called a self-assigned IP.
Okay.
So if you fire up your device and it can't find a router or a DHCP server, it doesn't know what to do, so it specifically assigns itself in that 192.254 range. So as soon as you see that, you know that device isn't seeing a router or a DHCP server, but it will still communicate, because the reason they use that particular range is then if you put up 2 or 3 devices and they can't find a router or DHCP server, they can still talk to each other.
Very nice.
Because
okay.
they'll wind up in that same range so they can talk to each other, you can get things configured. And the last one is a local host is 127.0.0.1. That is a public IP range, but it's blocked from anybody using, and that's your loopback host.
Gotcha.
And so if you just want, you say you have a router and you want it to look to itself, rather than send it out, or say a DHCP server, rather than send it out to the router and then back to itself through its IP number, you just use the local host and it talks directly to itself.
Very nice.
And,
Very cool.
And so that you use that, not a lot, but a fair amount.
Yeah.
And as long as you're in the same number range, the biggest problem people have on IP networking is they miss one of the numbers.
Yeah.
And as long as you're in the same range, they're going to talk to each other.
Very nice. So that's a lot of well, and the old joke, the local host. There's no place like 127.0.0.1.
That's right.
So
that's absolutely true.
There's no place like home.
Absolutely.
So, Claire, I really appreciate you stopping in and talking to us. That is a lot of information. We honestly, I'll be perfectly honest, I don't think we had enough time to talk about everything that we really wanted to talk about. So I would love, and we'll talk to the producers here in a little bit. We'll find out if we can have you come in for a part 2 or something like that.
Yeah, I'd love to talk about VPNs and VNCs and
exactly, be able to kind of dive in a little bit deeper to those pieces. So, guys, if that's what you want to see as well, leave a comment. Let us know that you liked it a lot, and we'll bring Claire back on for another visit with that.
Anytime.
We don't have Brent today. He's out working on a project off-site, so we don't have him today, but that's okay. We got Claire with us. So, guys, again, thanks for checking in with us. If you have more questions, please leave it in the comments below. We'll try and get to them later on or answer them in the comments. But we'll talk more about that next time. Because of the technical difficulties that we ran into, we'll revisit the free giveaway on the next episode. We might do something for that, maybe double up on it or whatnot. But we'll see you next time for that. And again, this is the Tech Tips with Metro Home Theater Group. I am Adam.
I'm Claire. Glad to be here.
Thanks for checking in with us, and we'll see you next time.